So now we're going to be simplifying when actually it's not just numbers inside. It could actually be variables too, because after all, this is algebra. And there is a pattern to it. You know, the square root, the fundamental thing is the square root of something squared. Those two operations, they undo each other, right? The square root of something squared is just whatever that thing is that you are taking the square root of, right? The square root of x squared is x, right? The square and the square root cancel each other out. So I look at something like x to the fourth. I mean, x to the fourth is, this is properties of exponents, x squared squared, right? So what is it that's being squared here? X squared, right? So when you take the square root of it, what comes out? X squared, right? Take it one more time. X to the sixth is x to the third squared. So when I take the square root, you know, what is it that was being squared inside the radical?
3.
X to the third. So that's what comes out. Okay. Now, honestly, the way I look at this, radicals like this, actually there is a number that's sitting right there in the hook that you don't see there. Now, you see it when we do the cube roots. Right? The cube roots look like this, and it's got an index of 3. You know what that means. For square roots, they don't put the 2 there because it's assumed. Right? If you don't see there's a number in there, that means it's a square root. That means that the index is 2. So instead of, like when I'm simplifying one of these here, I usually don't like write this thing so that I can take the square root of a perfect square. What I usually would do is divide the exponent inside by the index. That tells you how many of that thing come out. 2 divided by 2 is 1, x to the 1. Right? Look at x to the fourth. 4 divided by 2 is 2, x squared. Right? X to the sixth. 6 divided by 2 is x to the third. Okay, how about x to the 8th? How many are going to come out? 4. X to the 10th. 5, right? Just divide the exponent inside by the index, right? Exponent by the index. That's how many come out. X to the fourth, x to the fifth. All right, now it gets a little more complicated because we might have numbers underneath, and they might be perfect squares, which we did 2 days ago, or they might not be perfect squares, which we did yesterday. But for example, if I've got the square root of 4x squared, I'm going to think of it like 2 different problems, right? It's the square root of 4, and it's the square root of x squared, right? And I know the square root of 4, that's a perfect square, that's 2. And then how many x's come out? 2 divided by 2 is 1, so that's 2x. Yeah. Well, no, it's not dividing the 4 by 2. That's coincidence, right? Yeah. But it gets more complicated. We'll get to that slowly. We don't need to do it all in one slide. Okay, so now here's an example where you've got the x squared. We actually know what to do with that one. But 18 is not a perfect square. So how do we simplify that? We just did it in that worksheet you're working on. Okay, I mean, you could do it in your calculator. You know, treat it like 2 separate problems, right? The square root of 18, if you do our little process, is the square root of 9 times the square root of 2, and the square root of 9 is 3. Okay, but we also have the x squared. So how many x's come out? 1. So you've got to take that x also. So if it was just the square root of 18, you would have 3 times the square root of 2. But it's the square root of 18 x squared, so I've got to take out also an x. 3x times the square root of 2. So you usually put if there's a number and the variable, the number goes first and then the variable. Right? You don't write x3, even though it's technically it's right. You know, you can change the order of multiplication, commutative property, that's okay. But usually it would be written with the number and then the variable and then the square root. Right, so try to do that one. And if you have your worksheet that you did, we did the square root of 96 like on 2 different problems. So that part you've got. You just need to figure out how many x's from that x to the fourth come out? Right, this is your U try. What's that? You already did that problem, right? Don't reinvent the wheel. Yeah. Yeah, when you're done with the homework, I'll take that up. You can do it next time. Okay. Oh, no. What did I just do? Right. How did the square root of 96 simplify? Yeah, I mean, we did. This was like the first problem on your worksheet, right? Let me split it up. I'll call this the square root of 96 times the square root of x to the fourth. Okay, and we did this one, right? That was 16 times 6. So the square root of 16 is 4 times the square root of 6. Okay. Now, how many x's come out if you do the square root of x to the fourth? Right? Should be, I'm going to simplify it like this, times x squared. Right? It's 4 divided by this little invisible index of 2. Okay, now we wouldn't write it in that order. We'd always write the number goes first, the variable goes that's outside of the radical goes next, and the square root goes next. 4x squared times the square root of 6. No, you don't need that. You don't need a multiplication dot or anything there. That's a multiplication no matter what. Just like we didn't put a dot in between the 4 and the x squared either. A lot of times that's what we do. You're going to have to go through that process again. Go to y1. And, yeah. Okay, let's try and see how far we get here. So now, here's where it gets more complicated. Yeah, Drew. Okay. On the previous slide? On that? Okay, just that. It gets more complicated because actually, if I try to divide 3 by 2, it doesn't divide evenly. So actually, all the x's are not coming out of that square root. So we're going to, just like we have to take 96 and split it into 2 factors, one which we can simplify and one that we can't, we do the same thing with x to the third. Let's break it up, properties of exponents. X to the third equals x squared times x, right? Because you add the exponents, 2 plus 1 is 3. So then I can take the square root of x squared because 2 is an even number. That simplifies. The square root of x, I can't simplify. So that stays. So it's x times the square root of x. So when you have like an odd number there, you're going to have one x that stays behind and then the rest will come out. Like here's x to the fifth, right? 5 divided by 2 doesn't go. So I split it up into x to the fourth times x, right? Now x to the fourth I can simplify because 4 divided by 2, that goes. All right. How many x's come out of x, the square root of x to the fourth? 2. 4 divided by 2 is 2. And this square root of x, that just has to stay. There'll be some part that you can't take out. Okay, try that one. X to the 7th. How many x's are going to come out? What's going to stay inside? Did you figure that? That's not right. What? Did you put that in? Oh, you're already on the next page. Okay. Well, on the next page, that's got to be x to the third. and x to the third, not x squared, because it's cubed roots. Right? How are you going to split up those x's? Right? I'm going to make it x to the 6th times x, because doesn't that equal x to the 7th? Yeah. Because of properties of exponents, you add the exponents. So I can make this the square root of x to the 6th times the square root of x. And now how many x's come out of the square root of x to the 6th? 6 divided by 2? 3. Right? Okay, so we can also have more than one variable under there. And then you'll just have to treat each one as its own thing, right? The square root of x squared, y squared, both of those exponents are even, so I can take them both out, right? 2 divided by 2, x to the first, y to the first. But it could be that maybe one of them's even and one of them's not. So what would I be able to take out of this one? The y would come out right away. Can I take out all the x's? Yeah, I could split the x's up into x squared times x, right? And then get the most simplification that I can. So that would look like this, right? I would say this is usually the way I write this. I'll go like this. I'll say this is x squared. This is the square root of x squared times the square root of x times the square root of y squared. I broke it into 3. And now I'll simplify what I can. The square root of x squared is x. The square root of x cannot be simplified. The square root of y squared is y, right? And now I should rewrite that with everything that's outside is in front, xy, and the square root of x. Right? What's this one going to look like now? If it's x to the third, y to the third. Now neither one of them, Julian. Yeah, I mean, just like we did with the x is going to be x times the square root of x. And what is the y going to be now? Y times the square root of y, right? So we got to split up both the x's and the y's so that we can simplify something. Right? So this will be, I'll write it down here. This equals the square root of x squared times the square root of x times the square root of y squared times the square root of y, right? Now I can simplify the square root of x squared, but I can't simplify the square root of x. I can simplify the square root of y squared, but I can't simplify the square root of y. Now I'm going to put everything together which is outside the radical, xy, and everything together that's inside the radical, xy. Done. So again, you could have variables that are raised to different powers. Sometimes they all come out, sometimes they don't. You could have multiple variables. You could have numbers involved, and you have to, treat them all separately and then put them together at the end. Okay. What will I do in this one? Do I need to split up the x to the 5th? Yeah, I have to, right? Because 5 doesn't divide by 2. I have to split this into, right? So how am I going to split up the x to the 5th? How am I going to split up x to the 5th? Somebody. X to the 4th times x. What about the y to the 8th? Do I need to split that one up? No, it's already an even exponent, right? So they'll all come out. So I'm not going to do that one. I'm just going to say this is y to the 8th. And then I'll take the square root and the square root and the square root. Okay, what is the square root of x to the 4th? Nope. X squared, right? The square root of x cannot be simplified. What is the square root of y to the 8th? Y to the 4th. And now we just need to put everything together that's outside the radical, x squared y to the 4th. And everything that's in the radical just consists of an x. And try that one. This is the properties of exponents. What's the first thing you should do to this one? What do you do with anything to the 0 power? Replace it with a 1. Here, just get rid of it. So just rewrite the problem without a z to the 0. Z to the 0 equals 1. Hopefully you got that on the quiz, right? Hopefully, Todd. You don't remember if you did?
I don't know.
Mm-hmm. You done? Thank you. Okay. Who's got it? Besides Connor. Ty.
Y squared x cubed, and then the thing y. Right. Yeah. No.
So y squared x cubed. Don't think we're on the right track. Somebody. Who's, well, Sid. No. Connor.
1 cubed y squared square root of 1.
What'd you say about the x's? X cubed. Okay. So all the x's should come out. X to the third. And then the y to the third? Y times the square root of y. So I would rewrite this right away. Just rewrite it like x to the 6th, y to the 3rd, right? Because we don't need that z to the 0. That equals 1 anyway. And then all of the x's are going to come out. So I don't simplify that. But I do have to split up the y's into y squared times y. And now the square root of x to the 6th, x to the 3rd. The square root of y squared, y. The square root of y can't be simplified. Done. That's it. No, because you simplified the square root of y squared. So x to the 3rd y times the square root of y. And we're not going to do, we don't have time for the rest. So what I'll do on Monday, we'll pick this up again, and I'll give you another worksheet for homework, which you'll do in class. They'll delay the test to Wednesday.